before we move on to objective 2, I was just thinking I'd like to give you another example of finding inverses, specifically with one that's not a line, because a line, when you flip-flop it, it's still a line. But these other functions that are a little bit more intricate with powers and so forth, it doesn't seem as obvious, okay? So let's just write, and you don't have to do this, you can just follow along with me. Find the inverse for f of x equals x to the third minus 5. Okay? So we are going to find, and example 5 that we're going to do in a second, guys, isn't going to take up a whole lot of room. So if you do want to write this off to the side in your notes, so if you just use like this half for us to do example 5 and this half to do this example, that should be fine. All right, so we're going to find the inverse of f of x equals x cubed minus 5, just following our 4 steps that we had before. I'm going to put them over there. Okay? So step number 1 says take your function, but instead of f of x, replace it with y. So this is y equals x to the third minus 5. Is that step okay? Step number 2 says make the inverse happen, meaning let's flip-flop our x's with our y's. So 2 is x equals y cubed minus 5. Step 3 says, you technically have the inverse now, but functions are always y equals, like the y is always isolated. So let's go ahead and isolate y. So what's the first move we're going to make to get y by itself? Add the 5 over. So on number 3, we'll have x plus 5 equals y to the third. Does that look okay so far? And then this is where you take everything we've learned so far up until this point in the semester. What's the inverse operation of cubing? Not cube rooting. Exactly right. So what we're going to do is we're going to take the cube root of both sides. But when you do that, the cube and the cube root are inverse operations, so you're going to have y equals the cube root of x plus 5. So hopefully that makes sense to you guys. The opposite of a cube polynomial will be a cube root polynomial. The opposite of a square would be a square root, and so forth, all right? So step number 4 just says, hey, you already found it, but instead of using y, let's use the inverse notation. So step number 4 would just mean f inverse of x is just the cube root of x plus 5. And they don't have us do it, but we could easily graph this. The cube function, if you remember, is just that snake, but minus 5 just means it's been shifted down 5. 1, 2, 3, 4, 5. So he's just like this. Ooh. Okay? But the cube root function is a snake on this side, all right? But we're going to do what? Be to the left 5. And it's hard to do, but you're going woo, like that. And what do you notice about the 2 graphs? It's symmetric about the line y equals x, okay? So if you've done it correctly, you can throw it in your calculator. And what's nice is you can always throw it in your calculator because we'll always be isolating y. So, because this is technically an inverse, guys, but you can't put x equals y cubed minus 5 in your calculator, right? You have to have y isolated. All right, so that's good practice, and we'll do a worksheet here in a second, so if you have more questions over finding the inverses, just let me know. But what we're going to do is we're going to finish our notes with this one last idea. I think, I'm trying to decide, I'll probably have it on your test where I'll just say, prove that f and S inverse are each other's inverses, okay? And one way to do it is take the composition. The composition of functions is one of the things we learned earlier on with the semester. Remember it looked like fog? It was f of g of x, where f on the outside was the big function, g of x was the small, it's what you plugged in, okay? So the left was always your outermost, the inside, or your right was your inner, and you just flip-flopped it, okay? So objective 2 just says, if f composed with its inverse equals x, and f's inverse composed with f equals x, then you know you found the right inverses, okay? So what we can do is just compose one with the other and vice versa. And if we equal x on both sides, we know this is the inverse of that. All right, and that's what my math lab will have you do. All right, so let's find the first one, f composed with its inverse. F composed with its inverse. So really, they're the same size, but remember I kind of exaggerate my outside. So this is f composed with f inverse. So I kind of exaggerate the outside. And what does this mean? It means in my function f, in for x, what am I plugging in? The whole function of the inverse. All right? Well, what is f? F is 5 times whatever x is plus 8. So we're going to have 5 times whatever x is plus 8. Do you guys see there? Here's 5x plus 8. Do you remember doing this? Alrighty, how's this going to clean up? What is going to happen with these two 5s? They're going to cancel. So this is x minus 8 plus 8. But what's going to happen with the negative 8 and the 8? And you're left 2n x. Woohoo! That's what they said it's supposed to do, right? And I'm pretty sure, you know what, I haven't played around with it. I'm pretty sure if it works one way, it's guaranteed to work the other way, but maybe not. I'm almost kind of curious to go find something that works one way but not the other, but we have to just do the other direction, okay? What does that mean? It means f inverse is going to be the outside function now, okay? So f inverse will be the outside, and f of x will be what we plug in for x. Okay? So what is f inverse? It's the quantity x minus 8 over 5. Okay, so that's going to be our main function. But in for x, we're going to plug 5x plus 8. So here's x, 5x plus 8. So there's my x, minus 8 over 5. Whenever I plug in a quantity, I always put parentheses around it, but were those parentheses really needed? No, because I don't need to distribute a negative. I don't need to distribute any kind of number. So imagine that the parentheses were not there. What's going to happen up top? The 8s are going to cancel out, right? That positive 8 will cancel out with that negative 8. So let's go ahead and cancel those out. So what are you left with? 5x over 5, which will just be 1x. All right, so we just proved that f and its inverse are the true inverses of each other because one composed with the other kind of all cancel out. So the very last thing, guys, is just, I know I started a lot, but this is just everything we talked about today. Every relation has an inverse. All you have to do is flip-flop an x's and y's. Every relationship, its graph and its inverse will be reflected about the y equals x, but not every relation is a one-to-one function, okay? So if you have a relation where its opposite is a function, then it's a one-to-one function, okay? And then if you pass the horizontal line test, that's how you know it's a one-to-one function, and then a proof to know that you found the correct inverse. So if you just wanted to check, hey, did I find it right? One way to do it would be throw in your calculator, see if they reflect about the y equals x line, or another way to do it is do the composition of both, and you'll have it.